Welcome back, guys, and this is another video assignment of the subject database management systems, and we are going to be talking about the topic functional dependencies. And my name is Parinitham, and I'm studying in Sri Venkateswara College of Engineering, pursuing fifth sem in the course Computer Science, Engineering, and Artificial Intelligence. Let's talk about the introduction. A functional dependency in a database refers to the relationship between two sets of attributes within a relation. Understanding and properly identifying functional dependencies is crucial in database design and normalization. It allows us for the minimization of redundancy and helps maintain data integrity. By recognizing the dependencies between attributes, organizations and can create efficient and well-organized databases. Let's talk about the definition. Key terms. In context to relational databases, functional dependencies involve a relationship between attributes. One of the key terms related to functional dependencies is the superkey, which is a set of attributes that can uniquely identify a tuple with a relation. Formal definition. A functional dependency is a constraint between two sets of attributes in a relation from a database. It signifies that a particular set of attributes uniquely determines another set of attributes within the same relation. Examples of functional dependencies. Employee information, employee information, and course schedules. Functional dependencies are constraints between attributes in a relational database. They represent relationship between attributes such as knowing the value of one attribute uniquely determines value of another attribute. Student ID and student name is an example. In a table containing student records, if student ID is the primary key and then knowing the student ID uniquely determines student's name, each student ID corresponds to only one student name, course code, and course title. In a table containing course information, if the course code uniquely identifies a course, then knowing the course code uniquely determines the course title. Each course represent corresponds to only one course title, employee ID and project ID. In a table recording a house employee project assignments, if an employee work on only one project at a time, then the combination of employee ID and project ID uniquely determines the hours of work by the employee on that project, zip code and city or state. In a table containing zip code information, if zip code uniquely identifies the geographical area, they knowing the zip code uniquely determines the corresponding city and state. Rules for determining functional dependencies. Determining functional dependencies is crucial for database normalization and ensuring data integrity. Here are the rules. Single valued attributes. If each instance of one attribute in a relation uniquely determines the value of another attribute, then a functional dependency exists. Composite attributes. In case where attributes are, that is, they consist of multiple sub-attributes, functional dependencies can still be defined based on subsets of composite attributes. Transitivity. If A determines B and B determines C, then A determines C. This transitive property helps identify functional dependencies indirectly. Trivial functional dependencies. Every attribute or combination of attributes trivially determines itself. For example, A tends to A is always true. Closure of attributes. To determine all functional dependencies, compute the closure of attributes. The closure of attributes A with respect to a set of functional dependencies F, denoted as A star, is the set of all attributes B such that a functional that a functionally such that A functionally determines B. Intra-set dependency. No two distinct tuples can have the same values in a set of attributes on the left-hand side of the functional dependency. Let's talk about the closure of functional dependencies, transitive and reflexive rule. If A tends to B and B tends to C, then A tends to C. The transitive rule helps determine the closure of functional dependencies and identifies all possible functional dependencies in a relation. Reflexive rule. If B is a subset of A, then A tends to B. This reflexive rule assists in evaluating the full closure of functional dependencies within a relation. Normalization using functional dependencies. Normalization is basically the process of the attributes and tables of a relation database to minimize the redundancy and dependency. Functional dependencies play a crucial role in this process. The first normal 1F. Now, for the first normal form, ensures each attribute in relation contains only atomic values, indivisible values, eliminates repeating groups by creating separate tables. Second normal form, relation must be in 1NF, remove partial dependencies by ensuring that non-key attributes are fully functionally dependent on the entire primary key. If a relation has a composite primary key, each non-key attribute must be functionally dependent on the entire composite key. Third normal form. This relation must be in N2NF, remove transitive dependencies for ensuring that the non-key attributes are non-transitively dependent. If A tends to B and B tends to C, then A should not transitively determine C. BCNF, Boy's code normal form, a stricter form of 3NF. Every determinant, every attribute on the left side of the functional dependency must be a candidate key. This ensures that there is no trivial functional dependency in a dependency on a superkey. Fourth normal form. The relation must be in PCNF. Remove multiple multi-value dependencies where one attribute uniquely determines another attribute, but not vice versa. Decomposes to represent each multiple value dependency separately. So now let's talk about the limitations of functional dependencies. Limited representation. Functional dependencies can only capture certain type of constraints between attributes. They are primarily concerned with one-to-one mapping between sets of attributes which may not fully represent complex relations. Inability to capture contextual dependencies. Functional dependencies do not consider contextual dependencies that may exist in the data. In some cases, a relationship between specific between attributes may depend on specific conditions or contexts that cannot be captured or solved by FDs. Inability to capture contextual dependencies. Functional dependencies do not consider contextual dependencies that may exist in the data. In some cases, the relationship between attributes may depend on specific conditions or context that cannot be captured solely by FDs. Multi-value dependencies. Functional dependencies do not address multi-value dependencies, which can result in issues in certain databases scenarios. Functional dependencies may not fully capture the intricacies of certain data structures, leading to potential anomalies at time. Summary, key takeaways. Functional dependencies provide a means to understand the relationship between attributes and are essential for database normalization and integrity. Role in data DBMS. Functional dependencies play a crucial role in the development and maintenance of efficient, organized, and reliable database systems. If you have found anything useful information by watching this video, please leave a like and subscribe. Thank you, guys.